In this video, you're going to learn about our next learning target, which is calculating the probability of a sequence of events. So this means you're going to calculate the probability of something given something else. Okay, so first we need to think about independent events versus dependent events. So sometimes things happen one right after the other, and the first event has no influence on the occurrence of another. So my example of this would be flipping a coin. I'm going to flip a coin over and over again, but it doesn't have anything to do with the first flip, whether or not I get a heads or tails on the second flip, okay? And then for dependent events, that's when they're influenced by the outcome of a previous event. Sometimes they're also called conditional. Okay, so like if I was pulling marbles out of a jar and I wasn't putting them back in, then my probability of getting the next one, the next marble in the jar would be greater for getting, the next one because there's less marbles in the jar the second time. The probability of getting a different color is going to change the second time. So the multiplication rule applies to both of these things, but just a little bit different. So the multiplication rule for independence is the probability of A and B and C and so on and so forth is just the probability of A multiplied by the probability of B multiplied by the probability of C. Okay, so the probability that a sequence of events will occur can be found by multiplying the probability of the events. When we do the multiplication rule dependent, we have to think about the second one that we are going to think about, the second probability. We have to think about the probability of A given that B has already happened. Okay, so we have to think about what what this probability is going to be. It might be a little bit different than what we've done in the past. So in the first example, we're thinking about flipping a coin. So like I said, this is independent. So no matter what, the probability of heads and tails stays at a half every single time, okay? Because the coin doesn't change no matter how many times I flip it, okay? So the probability of getting each of these things is a fourth, because that would be a half times a half, or you can look at the fact that there are 4 different outcomes and each one is equally likely because it doesn't matter what we get the first time to depend on the second time. What is the probability she'll get exactly one head? Well, that's these 2 outcomes. So that's 1/4 plus 1/4, which is half of the time she'll get one head. And then the next question says if she flips a coin 3 times, what's the probability she'll get exactly 2 heads? So you could either go heads, heads, tails, heads, tails, heads, or tails, head. No, that's not it. This one's not one. Exactly 2 heads. Let's see. You get heads the first 2 times, and then tails. You get heads, then tails, and then heads again. Or you could get tails, heads, heads. Okay, here we go. This just wasn't written right. Tails, heads, heads. Okay, so those are the 3 ways that you could get heads exactly twice. So you just want to think about the probabilities along each of those pathways, which obviously each one is a half. So we're going to multiply a half 3 times, which will give us 1/8 for each one. And then adding those together, that gives us 3/8 of the time she'll get exactly 2 heads. All right, the next one is a little bit more complicated. This is saying Cheryl makes 75% of her first tries at the free throw line. So a good shot and a miss, I'm going to think about 0.75 and 0.25 for the first shot, okay? And then it says that her records indicate that her success on the second throw depends on whether her first throw was good or a miss. She'll make 80% of her second throws when she makes her first shot. So if she makes it, and we look at this one, if she does make the first one, then the probability of a good shot given a first good shot is 80%. Okay, which means 20% of the time she misses once she's gotten a first shot good. And then when we go down here, it says she only makes 50% of her second throws if she misses. So she's got a 50-50 chance of a good or a miss if she misses the first shot. What's the probability of her making 2 consecutive good shots? So we're looking at this probability. So we're going to do 0.8 times 0.75 which is 0.6, or 60% of the time. She will make 2 good shots in a row. Okay? All right, so before class, I want you to think about this situation and bring your answer with you.